Right, it is 1,500 hours. Who would like to learn about some property-based testing? Woo! Yes, that's what I like to hear. So, in case we haven't met, which is most of you, I will admit, my name is Lucy. There's a picture of me on a good day. This is me on a Friday after having been at a conference for 3 days. So prefer pronouns she, they. I work at a place called Codat. I build front-end stuff. Codat does financial software APIs for things like QuickBooks and Xero. If you're in the market of building financial integrations, let me know. I might be able to hook you up with some good APIs. So I currently work in front-end land using TypeScript and React, but previously I worked in .NET and Angular, unfortunately. I love functional programming. I run the F# group at Codat. Who here likes F#? Oh, wow, that's amazing. That's so much better than I expected. I love functional programming. If you want to come talk to me about functional programming, that would be fantastic. If you want to talk to me about not work things, that's me on a boat. I like making things. I love knitting. Only hats and scarves because jumpers are too complicated for me. I like sewing. I like making myself outfits. I love making PowerPoints. I spent way too much time making this PowerPoint, so I do hope you enjoy. I went to RuPaul's DragCon UK early this month, and I met Lawrence Chaney, if any of you know who that is. And I went to Svalbard last year, and I saw a polar bear, and I definitely took this photo, I promise. So someone who is much cleverer than me told me that I should put the conclusion at the start so people know what we're aiming for. So conclusion. Property-based testing is a technique for testing statements of the type for all X that satisfy some precondition, some predicate will hold. It can give you confidence that your code behaves correctly across a wide range of inputs. And it can help you find bugs in your code resulting from inputs you never would have thought to test. And this technique can be used alongside existing unit tests. And if you really want to, you could use it tomorrow, but I have better things to do on a Saturday. So, question to get us all started. Who here knows what property-based testing is? Fantastic. So, only got a few people. Part of my hecklers know what it is, but that means I can lie to you, tell you about this wonderful thing that doesn't exist.
On the last slide, though.
Trust me, I made this up. I'm a genius. I came up with this myself. So let's jump straight in. Let's go through a scenario. I am a senior developer, and you have joined my company as an intern. This is you. You're looking very cute on your first day of work. In my company, we use F#, functional programming, and test-driven development. Who likes functional programming? Who likes test-driven development? Oh, who doesn't use goodness me. So we're going to write a list reverse function for, don't ask me why, but we're doing it. So I give you the skeleton for it, and you kind of look at it and you go, oh my gosh, it's F#, I don't know what F# is. So let's just talk through it quickly. So I define a function called list reverse. It takes a single argument, which is a list of integers. It will return a list of integers. And the implementation will go here. For now, I'm just making it throw an error. We'll look at it later. So it's not so scary. Who thinks F# scary? Good. So what should we do next? We might want to jump straight in and be like, yeah, let's implement the function. But no, we do test-driven development here. I love test-driven development. It's great. Let's follow the principles where we'll write the test first. I'm assuming you all know what test-driven development is. But the first thing we'll do, we'll write a test. So this is a test for our code. It's written in F#. It's using NUnit FS unit. Again, oh, here you go. Have a bit of time to read the slide. Now, tell me, who actually read the slide and who just watched the line? So if you don't know what F# testing looks like, here's just going over it quickly so we're all on the same page. So using NUnit and FS unit, it's a pretty standard library for .NET testing. FS unit just gives a bit of syntactic sugar on top, so it's nice and friendly to write in F#. We've got the name of our test, which is written in double backticks, and technically this is a variable which has got a name with a space in it, but, you know. We're setting up our test, so one thing you might have noticed, F# does use semicolon as a list delimiter, and there's nothing you can do about it, you just have to accept that fact. So we're making a list 1, 2, 3, and we're going to say, oh, I'm going to reverse the list, and next I'm going to assert it is as it's written. You don't need to worry about the funny symbol. I'm just saying the reverse list should equal 3, 2, 1. And you're like, cool, that's not so bad. This is great. Work is going great on my first day. We run the test, and it fails as we expect because there's no implementation. Let's add another test for our edge case of the empty list. So let's implement. Picture mostly unrelated, just making good use of my stock image library access. So I'll give you a bit of time to think. How are you going to implement this function? So the answer is, of course, you do this. So, if anyone who doesn't know F#, the translation for this is, if the list is 1, 2, 3, then return the list 3, 2, 1. Otherwise, just return the empty list. So, you run the test, they pass, which means test-driven development, we've done it right. We've written the test, we've written our code, everything passes, great. I think it's time for a nap and to prepare your letter to get promoted to senior software developer because you are ready. So, sometime later, in the dead of night, I come along and I try and run list reverse on the list 6, 7, 8, and I get an empty list. And then I'm just there being like, well, what on earth's going on? Why is this function not working? I should get the list 8, 7, 6, I get an empty list. So I come back and I say, okay, I'm going to write a new unit test. I'm going to say, if I reverse the list 6, 7, 8, I should get the list 8, 7, 6. It fails as I expect. I give it back to you, and you have to, go, I should update my implementation. Any guesses what the implementation will be? It is, of course, ta-da! If we're given the list 6, 7, 8, then please give me back the list 8, 7, 6. I'm sure you're sat there thinking, this is ridiculous, no one would do this, this is stupid. And then I remembered, I'm standing up here, I'm a developer, I'm going to convince you this is in fact the logical thing to do. So, please don't read this page. It is from test-driven development page on Wikipedia. We're just going to zoom into this bit number 3. So part of the test-driven development cycle, you write the test, you check they fail, and then you write the simplest code that passes the new test. And, okay, my example, it was list reversal. But let's say you didn't know it was list reversal. Let's say you were just given this mystery function that you had to implement, and you were just given these 3 tests as a specification. So what is the simplest implementation? I mean, it is, of course, a match statement. We are making assumptions that anything that isn't specified, we're just returning an empty list. We're just returning some kind of sensible default. We could also throw an exception if we wanted to. We could return anything, really. If anyone studied C++ at university and had to look at undefined behavior and scarred me for life, technically speaking, anything other than this specification is undefined behavior. So we can do what we want. So in order to fully specify our reversal function, we could just add more test cases. But then someone could just come along and add more cases to the match statement. So this is from r/programmer humor, the finest subreddit under the sun. So clearly, this isn't the right approach. I don't know if someone cleverer than me is in the audience and can tell me how many unique integer lists you can get on a computer with some amount of memory. Like, please let me know, but there's a lot of lists. Like, that would be a very, very long function. And I'm really lazy. So let's take a step back and go, well, how do we actually define a function? So you define its behavior, you define what it does. So I could say, okay, well, list reversal, I'm just rearranging the items to be backwards. That's fine, right? But all I've really done in this case is said, well, backwards and reversal are just synonyms of each other. So me describing them as, oh, reversal is putting it all backwards doesn't make any sense. So what would happen if you tried to explain list reversal to an alien who, for some reason, knew perfect English, but didn't know what list reversing was? Any ideas? So what we can do instead is we can define some properties. Surprise, surprise. What is a property? That is, for all x that satisfy some precondition, some predicate will hold. So what are the properties of list reversal? Well, one of them is, for all lists, reversing it twice will give you the same list. For a non-empty list, if you reverse it, the first item will be the last item. Likewise, the last item will be the first item in the reverse list. Also, if you have a list that is a palindrome, you can reverse it and you'll get an equal list. And I'm sure there are more, but you get the point. How does this help us? Why am I identifying these properties? You can't possibly test it for every single input to this function. So what we're going to do instead, we're going to do a mathematical proof. Hands up if you've ever mathematically proved the properties of your code. I don't know about you. I'm a programmer. I'm nowhere near clever enough to write these proofs, but I was made to do it at university, and it was really bloody hard, and I always got it wrong. And I think if I had to mathematically prove all my code was correct, then I'd write 100 lines a year as a generous estimate. So there must be a better way. And I would like to just introduce something called property-based testing. The surprise of the century. I'm sure you've never heard of this phrase before, but you will by the end of it. You will. You'll understand exactly what it is. So property-based testing, unsurprisingly, we can use it to test properties. For all x that satisfy some precondition, some predicate will hold. In this example, we're going to check that given a list of integers, if I reverse it twice, I get the original list. So we can do an implementation of this with a library called fscheck. So fscheck is a .NET library. It is called fscheck. It is an F# library. It is intended for F#, but it's a .NET library, so you can use it for C# stuff. Isn't .NET amazing? So a property-based test in fscheck will look something a bit like this. So let's just go through the bits of what's happening. First, we write a function to specify the property. I always call my uncheck function because I am very creative. Then we specify what we are given with an argument to this check function. So given a list of integers means that my function is going to have one argument, which is a single integer list. Then we specify how to manipulate the inputs. In this case, I am going to run it through the F# standard library list reversal function twice. And then I'm going to assert with my standard library assertions, which is just should equal in this case. And finally, I just tell fscheck to run the test, and magic, it works. So let's run it. Let's look at the output. Great, we've got a green tick. Cool, end of story, brilliant, fantastic. Let's look at actually what it's doing under the hood. You might have seen in the input, it says here, it passed 100 tests. So if we put in a bit of logging, so we're just going to log what list it's giving us, we can see that fscheck's actually running our test, and it's generating many different lists for us. And we're going to put those lists into the property, check if it actually holds. The inputs start small. There is a kind of formal way of saying small, but informally understand, an empty list is smaller than a list of one item. They start small and they get bigger as it progresses. So the way fscheck generates these inputs is it's trying to find edge cases really quickly for you. So for example, it will start with an empty list. If you were testing numbers, it will start with like 0, 1, -1, infinity, not a number, all the crazy numbers you want. If you're testing strings, it will generate like empty string, random Unicode string, loads and loads of stuff it generates. Try and find your edge cases really quickly. On the flip side, in the case of a failure, what happens? So let's write a test. Reversing the list gives the original list. And, I pop up and I go, well, clearly it won't work for non-palindromic lists. And then, I run it and then, oh, look, little red box. Oh, that doesn't actually work. Looking at the output it gives us, cool. It's shown us the first input it ran that actually caused the failure. And then it's done something called shrinking, which is like, I'll just hand wave it away. It gives you a minimal input to cause a failure. In this case, the fact that we have a list that is just 0 and 1 is like the minimal item to cause a failure. If you want to investigate this bit more, you could just write a single unit test with this 0, 1, and you can debug it. It's great. Neat. So let's think about addition. Like, who can confidently stand up and tell me what is addition other than 1 + 1 = 2? Go for it. Do you want to?
Yeah, it's a binary function. Oh, sorry, it's a function that takes some number of inputs. Let's say, for example, 2, and it is. I want to say it would be, but it's you can do it either way.
Yeah.
And you get out a single number at the end. And that number, I know how to give you like the group stuff.
Yeah. So let's pretend again. I know this isn't the UFO talk, but there's an alien. Do you want to watch it again? Oh no, wrong button. Oh no, oh well. Yeah, so if you go onto the dark place of maths Wikipedia and you look up addition, and you will find this lovely little section which is called properties. Conveniently, is exactly the kind of thing we could test to see if our function that takes 2 numbers and gives us another number is addition. So for addition, we have commutativity, that is a plus b equals b plus a. We've got associativity, which is a plus b plus c is the same as a plus b plus c. And then we have the identity element of 0, so if you take something and add 0 to it, you get the same thing. So if we, for some reason, I don't really know why, decided to write our own add function, we could prove there is addition by just testing these properties. So for example, I will take my 2 inputs and swap them around, and if this test holds, I can say it's commutative. Not a proof, but we can use property-based testing to just give us a very high confidence that it is commutative. We can test associativity by doing pretty much the same thing. So we can apply our function to 2 of the variables, 2 of the inputs first, and then the other 2 inputs, see if we get the same answer. And we can check the 0 identity. So just take anything and add 0 to it, and you should get the same thing. So this isn't a proof that our function is addition. But as I said before, I'm not a mathematician, I'm a programmer. I've never done a mathematical proof of any of my code works, but I could run this and I can be like, I'm pretty sure it's addition, and that's good enough for me. So you are there and you look at this and you go, meow, meow, because you're a cat and you can't talk, which obviously translates to, I understand addition so much more now. And this is just showing that with property-based testing, you can analyze your functions and understand them a bit better. So anyone who sat there was like, oh, Jesus Christ, I don't care about addition. I'm not a mathematician. I know 1 + 1 is 2, and that's fine for me. I understand proving that our addition is a bit abstract, but let's have a look at it in real life, where you might actually want to use it. So Scenario number 1, you may want to use it, is there might be some randomness in your code. So I have used this before. I had a scenario where I had some code that, given a single list, it will randomly remove one element from the list and it will give you the rest of the list. How on earth are you meant to unit test this? You expect to get something different every single time. You can't write a unit test for it, other than just fixing the random input, but then you don't know if it's actually working. It might just always return the element 4. How do you know? And that's where property-based testing comes in. So if we've got our function remove random, which takes a list of items and returns a single item and the rest of the list, indicated by a star here, what I can do is I can say, oh, let's write a property-based test for it. For if I take the two values returned to me and smush them together, I should get the same list. So if we quickly run through this, just to show you, hey, property-based testing is really cool. First of all, I can make sure my mouse is actually in the right place on the screen because I don't have a clicker. First of all, we're just going to ignore empty lists. If fscheck gives us an empty list, just kind of ignore it. You can tell fscheck to filter out stuff you don't want, but for this, we'll just do this. We'll take the two return values, so the removed item, the rest of the list. We will smush it together with this lovely list cons operator. And then we are going to check equivalence using this should be equivalent, which just checks that they are the same items but in a different order. And with that, we've now written a reliable test for something that is random and something different happens every single time. So, scenario number 2 you might want to use this for is when the solution is easy to verify but hard to prove. Let's say for some reason you are writing a sorting algorithm and you're like, I should probably test that this works. How would you prove a sorting algorithm actually works? Again, I'm not a mathematician. I have no idea. I think it's probably quite difficult. Thank you, Eli. What we could do instead is we can say, well, I don't really care if it's like proved correct, as long as it's like probably good enough. We could just run the sorting algorithm loads of times, run through the list, and check all the pairs are in order. Ta-da! So we write a property-based test, we sort the list, we shove it into this F# pairwise function, which does kind of exactly what you might expect. It generates the successive pairs in the list, and then just run through each pair and check it's in order. And now we've written a test that shows that our sort probably works. Beautiful. So the next scenario, I have lost count of which scenario we're on. I apologise. You may want to use it if you have an existing implementation to compare against. So, who has ever done this? You've got an old legacy function and you're writing a new function to replace it. Fantastic. It is a complete pain because you're always there being like, oh, there must be some edge case I've missed, some weird quirk where it doesn't work as it should and people have been relying on that and I don't want to break anything. So, guess what? We can use property-based testing for this. We can write a single 4-line test that just gives us random inputs, runs the refactored one, checks it's equal for the legacy function, run it through property-based testing, and hey presto, I have a 4-line test that just captures, in theory, every single edge case. It's amazing. I have done this before, and oh my god, it helped me sleep that night. Next one you might want to do. By the way, I should add, I have used property-based testing in all of these scenarios. This is actual IRL stuff. Next place you might want to use it, if you've got forward and reverse functions. So, example of that, serialization and deserialization. If you're me, and for some reason you're like, I know what would be a really fun thing to do this weekend, let's write a custom serializer and deserializer for my thing, because why not? And, surprise, surprise, you can use property-based testing for this. So you can just say, oh, get me an object, shove it into the serializer, deserialize it, check you get the original object back. Brilliant. You've tested your entire serialization, deserialization logic with a single test. It's fantastic. Even better, I had an issue with my custom serializers and deserializers. I added an optional property onto my object. Now, onto my class. Because it was optional, of course, there's no compiler errors. It's just everything I make doesn't have that thing. It's fine. My unit test would not have caught it. I would have had to remember to go in and update my unit test for this missing field. But property-based testing, it generates the objects for you. It generates objects with that optional field. It serializes them, deserializes them, and says, there's an issue. You've forgotten to serialize this field back, deserialize this field back, whichever one you've forgotten. And you're there being like, yes, brilliant, so good. So yeah, if you ever want to write custom serializers and deserializers, for some reason, let's be friends, but also property-based testing. This one is probably, so I did show this talk to my peers in my company, and this one was their favorite option, which is, I like to call the nuclear exception finding option, which is literally run the code and make sure it doesn't throw. And you can just write this tiny test. It will check it never throws, and if it does throw, it will go, hey, if you give it this thing, it throws. And you're like, oh my God, this is brilliant. It's so easy as well. And last but not least, you might want to use it to just check. You might want to use it when only some of the range of possible outcomes is actually valid. So, for example, if you you want to always verify that you return a positive number from your function. It seems a bit weird to suggest testing that something isn't correct. Well, you're testing that it's not wrong rather than testing it's correct. You might want to do this simply because it's easier. Like, you might want to say, okay, I know my function is always going to return a positive number. I don't know what that positive number is. I don't really care. I just want to check that it's always positive. And this is actually so useful because if somewhere else you're relying on it being non-negative, you should have a test for it. If you're relying on that behavior of it being non-negative, it should be in a test. If someone changes it, accidentally returns a negative number, they break a test and they can be like, maybe something's up here. Maybe I'm doing something wrong. Rather than just returning a random negative number and going like, woohoo, let's just see what breaks. So, as I said, I've used property-based testing IRL, but I've actually found case it being used in the wild, in production code. I would like to especially thank someone called Richard Sanderson Pope at my company. Woo! Come on, Cowpash, give me a woo. Yeah, thank you. So I just typed fscheck into searching all the repos at my company, and it came up with 74 references. This was before I ever gave this talk, so somebody else at my company is also a fan of fscheck. And I actually gave this talk at my company and then checked it again 4 months later, and it went up to 129. So I am single-handedly responsible for increasing the number of property-based tests at my company by about 50%. And I may have opened Pandora's box, but it seems okay. I'll admit most of this code just went around the route of just check it never throws, which can't use it for that, but... And if you're sat there thinking, I'm a front-end developer, I'm safe, this is .NET shit. No! Admittedly, when I made this talk, we are a company of .NET developers with JavaScript on the front end, so front-end devs. I've lost the ability to edit this text, so you'll just have to appreciate my attempt at hiding it. So JavaScript developers, you are not safe either. There is a library out there called FastCheck. And I just want to highlight this one because they have a fantastic page, it's amazing reading, called Issues Discovered, where they actually have published where they have found bugs in really big libraries. For example, Facebook's Jest. Who knows what Jest is? Clearly not front-end devs in the audience. Jest here, 4 million downloads a week as of May 2019. Jest is used for basically testing every single React front-end that is out there, so it's used a lot. And FastCheck found an issue where to strict equal fails to distinguish between 0 and 5 times 10 to the minus 324. Specifically that. But who on earth would have thought to write a test, let's check that 0 doesn't strict equal 5 times 10 to the minus 324. I wouldn't have thought about it. But FastCheck was there being like, I'm just going to generate all these random numbers and shove them at you and oh look, you lose. It's also checked that to equal was not symmetric for a set, and there's some strange thing here. I've read this a lot of times, still don't really understand what's going on. But the point is, who on earth would have gone, I'm going to write a unit test for these two examples? Probably no one. I never would have thought of it, but maybe that's just me being lazy. And if you're sat here going, well, I'm not a JavaScript developer or a .NET developer, sadly, you're not safe either. If you go onto the search engine of your choice and you type in property-based testing for one of my languages, you'll find myriad of frameworks. So Python, Haskell was the OG property-based testing, I believe. You've got Java, you've got Rust, you've got Ruby, you've got C for some reason. Who on earth is still using C? But you can property-based test in it. PHP, Go, I think you get the idea. It's like there's stuff for pretty much every language. And I did check if there was a property-based testing framework for brainfuck, and unfortunately there isn't. So esoteric programming language lovers, you're a bit out of luck. I did check it, and it doesn't exist, much to my disappointment. So you probably sat there, and you've probably got a few questions, and I'm just going to go over some questions that I've been asked before. So can I use this for complex types? Like, it's all well and good me coming up here and being like, yeah, I can test that my list reversal function works for integers. And you're sat there being like, I work in the real world, and we have like complicated objects and stuff like that. The answer is yes, with a big asterisk. Big asterisk stands for, basically your mileage may vary. Using this for complex types heavily depends on what language you are using. So to compare and contrast the two ones I've actually used, FSCheck and FastCheck, can I use this for complex types? For FSCheck, yes, you can. Let's say I'm writing a little simulation of an object moving across a table. I've got some physical properties, which is just the friction between the object and the table and the weight. And I've also got where the box is on the table, how fast it's going, and the physical properties.
Can't know both of those at once.
I wrote this in about a minute. Okay, it's the coefficient of friction. I can have that, right?
Oh, I was going for the uncertainty principle. You can't know the position.
This is a box. It doesn't count. It's limited by the precision of double precision floating point numbers rather than the uncertainty principle. But thank you for the correction. I will add it into my slides. So I write a property-based test for this. I'm going to check something. I don't know what it is. Let's just pop a breakpoint here and just check what it generates in the debugger. Oh, look, it's just generated the correct things for me. If you kind of have a look at this, you might realise that actually there are some really funny numbers in there. So FSCheck is just there being like, oh yeah, like -0, let's chuck that in. -0.0. The weight is negative infinity.
And it's got the same number that goes strict equal to 0.
Yeah, I think this is like the delta of a double precision floating point number or something. It's something like that.
Magic number that makes computers cry.
Yes, exactly. So FSCheck tries to generate things to find edge cases as quickly as possible. In which case, in this case, negative infinity for the weight. This number that makes computers cry, -0. Not a number. things like that. This is intentional for the framework. If you have a look at our code, we are saying we're using doubles. Doubles, you can put negative infinity in. So in theory, our code should support the case when our weight is negative infinity weight. Our box is a black hole, but the opposite. I don't know. What you can do is you could say, that's stupid, I'm just going to say, okay, the weight has to be some number between 1 and 100, something like that. You can constrain your test to only generate sensible values, but then you have to beware that you're now kind of saying that is the domain of your solution. On the other hand, fast check for JavaScript and TypeScript, it's not so good. One of the big problems with doing this in JavaScript is, of course, the runtime typing is exceedingly lax, / basically non-existent. Even if you use TypeScript, TypeScript interfaces are compile time only. You cannot use them at runtime. If you have interfaces, you cannot use that to generate an object. So again, I've got the same problem, the same interface, but this time written in TypeScript. If I want to do a property-based test for this, I have to rewrite it as a fast check arbitrary, kind of like write something like this. It's not... I'll have a bit of time to read the slide if you'd like, while I have some water. So before you want to write any tests for your complex types, you have to rewrite them as a fast check arbitrary, which is not ideal. If you've got lots of objects and you have to do this for every single time, it's a bit of a roadblock. It'd be nice if... Oh, my scarf's making a break for it. So to come back to this, can I use it for complex types? Yes, but your mileage may vary. Just beware. Next question is, are there any performance implications? I foolishly talked to my friend about this over dinner and we didn't stop talking about it for about 2 hours, so I might go off on one a bit here. I do apologise. The answer is yes, no, sort of. It depends on what you consider performance to be. So it is an unfortunate truth of our universe that if you do more stuff, it takes more time. And yeah, with property-based testing, you're doing more stuff. You might sit there and naively think, well, I'm running a test with 100 cases, so it's going to take 100 times as long. And you're like, 100x, oh gosh, no. But let's just analyse this for a second. And I will pop up here and I will say, I don't actually know how the test runner works under the hood, mostly because I just don't really care. It runs my tests and that's that. So I make 2 test fixtures. I have one that just checks that, true is equal to true. Wow. I write another one that says, give me a number and check that the number is equal to itself. Wow. The world's most useful test fixtures. And I copy and paste these 10 times, and I run them, and who wants to see what happens? Yeah! Oh, amazing! So I run them twice, and this is what happens. I did not cherry pick this. I ran it a few times. As you can see, the property-based tests take about 25 times longer than the traditional tests. Every time I ran it, it seemed to be around 10 to 50 times slower for the property-based tests. But this is where I might be making a complete fool of myself standing up here talking about this. If you have a look at the little thing at the top, so this is the Visual Studio test runner, it says that it spent 813 milliseconds running the tests, but it only spent 251 milliseconds actually running the tests. And even worse, if you click here and open it up, apparently only the first test actually took time to write. So I'm kind of sat here being like, I think something spooky is happening under the hood. But then I'm kind of there being like, I don't really care, it's milliseconds. I spend more time getting coffee every single day. Like, that isn't even enough to get an extra coffee. So, as I said, I foolishly talked to my friend about this over dinner, and we ended up having this kind of bit of a discussion. I thought I'd chuck it in here, because it might be interesting, on performance of your tests. So, as I'm sure all know, there's kind of three main categories of errors. You've got compiler errors, which is when you get the syntax wrong, or your types wrong, or something like that. And you know instantly, you get the red squiggly, you get the little red text telling you off, and you sat there and you go, I'm so sorry, Mr. TypeScript compiler, please forgive me. Then you've got runtime errors, so something throws an exception, it's not caught. And then, worst of all, you've got the logic errors. So this is when the code runs fine. It just gives you the wrong answer. You have no idea something's wrong until someone looks at it and goes, I think something's not right. And of course, the compile errors are the easiest to identify. You know instantly. You get a red squiggle and you go, oopsie. Logic errors are a bit hard. They are, oh God, I think this number's wrong. No, the number's not wrong. You're wrong. Who's wrong? I'm not wrong. I'm definitely never wrong ever. Oh dear. So, okay. I will admit, I love the TypeScript compiler. The TypeScript compiler is my best friend. Like, I want to take the TypeScript compiler out for dinner and just spend a bit of time with it. I personally am a fan of very, very strict type checking, and I find TypeScript is like really good for doing that. Even though runtime typing, we just won't think about that. Compile time typing, it's fantastic. So let's consider this code. We've got a function, takes two optional arguments, two numbers, We want to have the logic of, oh, you either have to give me both the numbers or neither of them. And I might think, okay, I'll write the code like this. So I'll just take both numbers, I'll check if I've got A or B, A but not B, or B but not A, throw, and then just like do something. And, oh yes, have a bit of reading time. Look. PowerPoint has figured out this is a dark slide, so it's made the background black for this. I don't know why. Just a bit of fun. So if I'm using this function, I can write something like this. I can call it with nothing, I can call it one, I can call it with two things. That's fine. And TypeScript just sat there being like, yep, all good here. This is fine. This is absolutely fine. When we run it, for this one, of course, we'll get an error. So we'd have to write a test for that. We'd have to check, if I'm given one, I throw an error. Alternatively, I could write it like this. So I could say, I could gather up both of these into a single object, and that object itself is optional. When I call it, I have to call it like this, so I can call it with nothing, or I can call it with my object with both A and B. If I try and write this, TypeScript comes along and is like, no, you cannot do this. We get a nice red squiggly error, we look at ourselves and go, oopsie, I did an oopsie, I shouldn't have done that, oopsie daisy. But most importantly, I don't have to write a test for this. If I've got super strict type checking compiler, I don't have to test this. Like, there's no test for this, therefore there's no code to write for that test, and, pardon? Exactly, no code, no problem. The best code is no code. I'm sure we'll all agree. So in a way, by writing it like this, I've improved the performance of my test suite because I've got one fewer test to write. So I feel like people can't turn around to me and be like, oh, what about the performance of my unit tests if they're not doing stuff like this? Also, it's like, is this more or less performant in real life? I don't know, I don't care. I've got enough CPU cycles. I'm running bloody React and JavaScript and stuff. I don't care about performance to that degree. So I'm sat there being like, oh, TypeScript, I love you. Will you take me out for dinner? Will you marry me? And then I realized that actually, unfortunately, we live in the real world and compilers cannot save us from everything. And unfortunately, we do have these issues at runtime, which is what we have a comprehensive test suite for. And how can I have a talk about testing without mentioning my best friend, the testing pyramid? So, testing pyramid, you can basically break your tests into kind of three levels. At the bottom, you've got the lowly unit test, testing a single function, single function on its own. You've got like testing the least amount of code, quickest to run, quickest to write, good stuff. Have loads of these. Next up, integration tests, so testing a few components together or testing an entire service on its own. And at the top, end-to-end tests, so testing the real service in a real environment, doing real stuff with real databases, and takes a long time to write these, takes a long time to run them. And then right at the bottom here, this is my own addition. I've actually put the compiler down here because, of course, if you're using a type-checking compiler and you're using it properly, you don't have to write as many tests, which is why I think the compiler is the most important thing. But we can discuss later if you are using a dynamically typed language, not strongly, I don't know, whichever word it is. Anyway, property-based testing lives here. It lives in the unit test layer. You can turn up tomorrow, install your property-based testing framework and go over it. Pardon? Did someone say something? Okay, just me. So what does the testing pyramid save us from? So if I'm writing my code, I write with my best friend, the compiler. Get it merged into main after someone has diligently reviewed it. Get it built, run my unit tests, run my integration tests, push it out to a test environment, hope that it's not on fire, run my end-to-end tests, push it out to prod and really hope that it's not on fire. I've only caused 2 production outages so far in my career, and I think I'm doing really well. The point I want to say is that you kind of want to have as much testing as possible when you're writing your code and when you're building your code. And you can put property-based testing there before they can cause issues in production. And I don't know about you, I'd kind of rather spend a few extra seconds waiting for my unit tests to run than cause an outage, because outages are a bit longer than a few seconds. So my answer to does test suite performance really matter is like, no, in this case. It sounds scary to say that you might have a 30x increase and you might go, oh my God, that's so much. But then you're like, wow, it's like a few milliseconds. But I do have to put in here, maybe. So if you go away tomorrow and convert every single unit test that you've got into a property-based testing framework and increase your unit testing times by 30 times, that's not going to be seconds, that's going to be minutes. That's going to be a long time. Please do not do that. I'm not standing up here saying property-based testing everything. I'm saying this is a tool. Please, please use it responsibly. So the next question is, when shouldn't I use property-based testing? It's a machine, as promised. And I know you're sat here thinking, oh my gosh, I love property-based testing. It's my favorite new thing, my favorite new toy. I just want to go and take it, do everything with it. And then, you know, kind of a few months later, you're like, oh God, why did I think that was a good idea? Like on reflection, like it wasn't great. Now I'm looking back, I'm like, oh. So please do not shoot yourself in the foot with it. I'm going to say when you shouldn't use it, so you don't have to, wasn't that great animation? So please do not use property-based testing if you don't have standard unit tests. Like standard unit tests first, test specific examples, simply because they're just easier to understand. Please don't use property-based testing if standard unit tests are fine. You might sit there and think, I don't need to really care about this thing. I've only got a limited number of inputs. I can just test every single input works correctly. That's fine. Just stick with standard unit tests. Don't use it when you want to test a specific case, specific edge case. Property-based testing, no, it's just the opposite of that. One problem with property-based testing is it can be really hard to identify suitable properties. Sometimes if you've got real things, like classes doing real things, you might really struggle to identify properties. And also your properties may actually end up being as much code as the actual code itself. And there begs the question, who tests the unit test? Especially if you, so sometimes this can actually be indicative that you don't fully understand what your function is meant to be doing. So in the case of addition, if I'm just sat there being like, well, 1 + 1 is 2, then you might be like, yeah, but what's 3 + 4 then? That doesn't explain it to me. But I mean, I didn't understand what addition was from those properties, but I'm a computer scientist. Oh dear, oh, goodbye my scarf. Oh, I'm glad the microphone wasn't clipped to you. Next place you might want to use it is your models may not actually be suitable. As I showed before with the infinitely heavy box on the table, FScheck really likes generating mad numbers. I mean, you might be sat there being like, oh, I've said I'm using a double, but really I'm just using sensible doubles. And like, if you pass me a nan, well, I don't know what to do with that. And it's like, Should you possibly be using a different type that represents that it's a sensible double rather than just a double? I personally think so, but going back and rewriting all of your stuff just so you can kind of property-based test it isn't great. What you can do instead is you can instead say, hey, fscheck, I want you to generate my object, but only use like between 1 and 100 for the weight. You can do that, but it's going to be a big, big roadblock to getting implemented. And I'm here to convince you that this is great and easy and you should just try it out tomorrow. So you will all be very glad to know I am finished talking. In conclusion, hey, what a familiar looking slide. So in conclusion, property-based testing is a technique for testing statements of the type for all X that satisfy some precondition, some predicate holds. It can give you confidence that your code behaves correctly across a wide range of inputs. It can help you find bugs in your code resulting from inputs you never would have thought to test. And last but not least, this technique can be used alongside existing unit tests, and you can try it out tomorrow if you are so inclined. So with that, I will say thank you for listening.